I have this thought, and this is a general piece of advice, but I don't know if I'm wrong. I feel that as teachers, if we want to
Mm-hmm.
create something with I feel like we need to know more than it, right? If I write a
Yes.
lesson, I write a
Mm-hmm.
task, and then I do it with AI, I'm still the expert. I know more
Mm-hmm.
about what I want to do and want to achieve than the AI. So
Yes.
I feel like maybe a general piece of advice for teachers is that if you want to creating with AI, I think is a good stance, but then you have
Mm-hmm.
to know more than it so that you can
Yeah.
edit it. And that is,
Mm.
I think, also a shortcoming of AI that I heard of recently, that you cannot rely on it 100%. So you have to work with it. And when you work with it, you need to know more than it to decide, right? Whether to
Mm.
accept
Mm.
something or to reject it.
Mm.
And that's why
Yeah.
sometimes it takes more time to do it. And then going back to Nick's advice, if it's not helpful, don't use it, right? But
Yeah.
but yeah, so and from the learner's perspective, my advice is to always think about your learning, not about
Mm.
using it as shortcuts, but using it
Mm.
for learning.
Mm.
And the
Mm.
general advice
Mm-hmm.
again that I have is, if you learn something, you have the knowledge for yourself, then
Mm.
Mm-hmm.
why do you give it up? Why do you give up the learning? So
Mm.
again, maybe just a general disposition or stance or perspective from the learners and the teachers, in case it's helpful for you to choose your tools.
Mm. Oh, this is
What the
great. This
point
is
Lynn
great
made,
advice. Mm.
yeah.
Mm. Yeah, yeah.
Sorry, just to underscore what Lynn made, like that is actually that's an observation that um I mean, I've experienced it in my own use of it, but that's also borne out by like tons of different observers who are like commenting on AI from all these different aspects, is that it's going to make mistakes. Like it's just guaranteed to make mistakes. It's not designed for quote unquote accuracy. It's not actually intelligent, right? It's
Mm.
doing next word prediction. And it turns out that if you're doing next word prediction over a data set that's the size of the internet, then uh, next word prediction looks a lot like, you know, saying factual information like an expert. But
Mm.
it's simply not doing that. And like there's this is like the conflation of sort of what language models actually do with what intelligence is, and they're not the same thing, right?
Mm.
So that's the point that Lynn was making, is like unless its outputs are something that you can directly inspect and understand when it's wrong. I mean, this is something that when I was at Google, they started basically forcing us to use AI coding agents, right? Whenever we were having to write software, and now things like GitHub Copilot are sort of like common practice. There's a lot of people that do this thing called vibe coding, where they let AI write all of it themselves, and that is total nonsense. But the only use case where they actually do something that is like saving you time or saving you keystrokes, essentially just like amount of time you spend typing on the keyboard, is if you know how to do it already and can
Mm.
just inspect the output, and it's just saving you a little bit of time. The point
Mm.
where you start trusting it beyond
Mm.
your uh your level of knowledge, or something that you truly understand, that's where you start to get into trouble. And I'm not saying never ever use it as is. I mean, there's low stakes situations where you might just want it to spit something out, but like you being aware that you're running into trouble when you do that is really important. I
Mm.
heard somebody yesterday um, on a podcast. They were talking about um, generating some kind of SEO information for something, and then like the chatbot started arguing with them about things that were actual facts that they knew were wrong. And I've had this experience myself. It just like it will confidently assert something that is patently false, and then you say you're wrong about that, and it says, "Oh, sorry, thank you for correcting me," right? Which is just like,
Yes.
and the
Like
thing is,
saying
it's
sorry very quickly.
yeah, yeah, but it's the thing is, people think like, oh, it realized it was wrong. It's like, no, it didn't realize it was wrong. It's that if you look at all of the data on the internet, where you have dialogues of people talking back and forth, like a Reddit thread or something like that,
Yeah.
when somebody says something and then somebody confidently says like, you're totally wrong, this is the reality, the most likely thing that follows, I mean, we all know the internet, a lot of times people just argue more, but like in a lot of cases the response is, oh yeah, you're right. Right. So it is just learned that pattern. And this is one of these things where it's just like the scale of the training data is beyond the, you know, anyone's comprehension, because there's just so much stuff that is being put into these things. I mean, some of these models are trained like the term, like the unit of training data is called a token. A token is just like the numeric representation of chunks of words, and on average there's something like 3 tokens per word and so on like that, but like that's just a rule of thumb. There's more or less for different words, but the token size, the size of the tokens that end up training these data sets are on the order of like 1 to 5 trillion tokens, right? And it's important to understand that like that is a number that is so far beyond, like you cannot read a trillion tokens in your entire lifetime, right? Nobody will, like, or in 100 lifetimes, right? So the amount of data that's being consumed by these things makes it such that it seems like they have knowledge of things that they don't actually have knowledge of. And what happens, and patterns that emerge in the dialogue that you have with them seem like it knows something, or it's actually interacting with you, but really it's just reproducing patterns of this exact dialogue or a similar dialogue on the internet. Like one thing that's I try to get people to do is like ask it to define something, right? Just say, give me a 1-sentence definition of black hole, right? And it'll say like, it's a region of space-time where the curvature is infinite or whatever, right? Take that exact text and Google it with quotes, and you'll find 5 or 6 web pages that have that exact line in there, right? So what it has done is it's memorized chunks of the internet that are, you know, basically just making factual statements. It has Wikipedia, it has, you know, and a bunch of other stuff that's not as trustworthy as Wikipedia. So the appearance of intelligence is actually just like a statistical artifact of how these things are trained and how they operate. So it's very important. Like, they're not intelligent. Like that's full stop. They are capable of indexing a bunch of information and sort of like serving it up if it's relevant to the question you asked. But intelligence is, no, that's not what we're looking at here. This is like the Eliza effect on steroids. We were talking about this a little bit before the chat, and John, feel free to stop me if I'm going long, whatever. But like
no, this is really useful. Yeah.
But like dialogue systems, again, this is, you know, natural language processing is not a new technology, right? These things have been around for a very, very long time. And the first chatbot, and a lot of people know about this thing, but they don't realize how old it is. But the Eliza bot was made in 1966 by this guy Joseph Weizenbaum at MIT, and he basically used rule-based natural language processing, where it's like, if you say something like my cat is orange or something like that, it can flip it and just say your cat is orange, and it just has a question. And the purpose was to simulate kind of the sort of like taking every sentence you say and just turning it into a question and throwing it back at you. And it was kind of a loosely simulating what like talk therapy is like. But its purpose, and this is the thing a lot of people forget, is like its purpose was to demonstrate that intelligence is something that you can fake if you just make it look like natural language, right? It was intended to show the opposite of what people actually took from it. Because what would happen is people would have these dialogues with Eliza, and again, this is 1966. This is written in like Fortran or something like that. I forget what like was originally written, but it's like very, very old technology. And people would dialogue with it, and they would be amazed that it's able to sit there and have almost open-ended dialogues that run on for multiple turns, right? Turns is like whenever one person says something and another person says something in response. It's like a turn of dialogue, right? So it could just go on for a very long time. And this thing of, they called it the Eliza effect, is that people would feel like it understood them, right? Even though it truly does not. It is rule-based. It is literally taking what you're saying, breaking it into chunks, looking for certain words, and then flipping the tense or adding a question mark or just doing like, and the code is not that long. You can literally read the code and see exactly what it's doing for every single situation. And yet the feeling you get when you use it has this, there's some kind of like, I don't know, it's sort of like when you see a face in a tree trunk or something like that. Like it seems like it's intelligent. It seems like there's something there that's not actually there. And even it wasn't actually until like, I think when they do like Turing tests, just for the sake, if anyone doesn't know what the Turing test is, the Turing test is this, it's essentially a test that was invented by, well, not invented, but it was suggested by Alan Turing as a way to determine whether or not a computer system is intelligent, right? And the idea was that you basically have like a barrier between the person and the computer system, and the person doesn't know whether or not the thing on the other side of the barrier that they're interacting with is a computer or a human. And the idea is that you just pass messages between the two, where the person is able to ask questions and respond, but doesn't actually know if they're talking to a person writing their responses down or a computer generating them. And if after a certain amount of time the person can't tell the difference, then it's considered intelligent. That's the it's more complicated, but that's the Turing test, right? And ELIZA, right, this 1966 program, by some criteria did better than ChatGPT, right? It wasn't until GPT-4 that there started to be like a real differentiation between these two. And the amount of training data that ELIZA required was 0. It was one person writing code that made rule-based responses to dialogue. And GPT-4 required, again, these trillions of tokens that they basically gleaned from downloading the entire public internet. So but dialogue systems have been improving all along this time, but like the basic thing that they're doing is just next word prediction. And that does kind of tie it back to Eduling, because like for our purposes, if we're trying to do task-oriented language learning, what you're trying to do is simulate dialogue, right? Yeah. And it's dialogue that from the literature and second language acquisition, certain types of dialogue work better. It's better when you have a task that is not based on learning language. You're not required to use a specific tense or a specific vocabulary word, right? You use language to accomplish the task. It's not the purpose of the task. So that kind of thing, we can simulate that with language models. So for Eduling's purposes, if we were making a dialogue system to simulate language teaching, a language model is what we would use. And if ChatGPT didn't exist, we would use something else, right? We'd probably have some kind of rule-based system, and we'd try our best. But this is kind of the original purpose for these types of models. But because of the size of the training data, they've now been applied to, be general purpose tools that can supposedly do anything. And some people are saying that they're going to destroy the world. But that's, a lot of that is hype. There's a huge chunk of this which is just hype. But I don't know, we see them in terms of just like their place in the pantheon of language technologies that have been developed over decades, and this is the ideal tool for the job that we're trying to do. So we use it cautiously. We know what the problems are, and you could probably tell from my own points that I'm making so far that like I'm not a booster for these things. I think that they're a tool. I don't think that they're a machine god. I don't think that they're going to destroy the world, and I don't think that most of what is said about them in the tech press is even remotely true. So there's that. But yeah. I also kind of, if you're in this space, you've kind of come through the long, arc of how we got to ChatGPT, right? So when I first got into this field, you'd learn about statistical language models, where basically you would just take a block of text, and then for every 2 words, you would figure out the probability of the next word being a certain word, right? So that's like this very simple, you just count how many times after a certain word, another word follows it. And then you add up the number of times it happens, divide that by the total, and then you have a probability, right? So that's like that's the very first statistical language model, which is just like, they call it n-gram models. And from there, people realize that like, okay, neural networks can do a decent job of this and can take in more information, or you can use, you know, recurrent models that have like this idea of like being able to look at the context and previous things that have been said before, as opposed to just taking the current tokens and going in and just predicting from there. And that led to things like BERT, which was like a predecessor to GPT. And then there was GPT-1, and then GPT-2, and then GPT-3, and then GPT 3.5, which became ChatGPT, and then GPT-4, and then 5, et cetera, right? So every one of these has been like an incremental improvement, some of them larger than others, but like none of them are, I mean, if you've seen like from the very first ones to the last ones, like none of these incremental improvements is, you know, a step change from the previous ones. There are certain things that were like fundamentally better and different, like GPT-3 was a massive improvement over GPT-2. But there's yeah.
So
Yeah,
maybe
stop me from talking. I'm just going on forever. I'm sorry.
that's
No,
okay.
no, no.
Nick and I are
No, no,
thinking
I
of
think
Nick and I are thinking of having a separate podcast talking about
no,
technology.
really, this has to be
Or-
in a podcast, you know, because no,
yeah,
I really like the way Nick he explains very technical stuff in very, how to say, easy to understand language. I
yeah,
mean,
and we are thinking about like
when
creating a
he
course.
Comprehensible input.
yeah,
Yeah,
yeah. I like when you use the word capability instead of intelligence, so people
Mhm.
understand. Like, yes, the core of the matter here, like Ling advises before, that is, you really have to be a critical user and think about how you leverage AI in general, yes, as a tool, yeah,
Mhm.
rather than like Nick. I want to quote him again, like how to say, machine god, something like that. That's very
That's Sam
interesting. I mean,
Altman talking. That's not
no,
me.
yeah, this might change totally the mindset of the people who are, you know, looking at using AI right now. So thank you
yeah.
so much for that.